everyone, we're going to find the derivative of the function using the definition of derivative. We're also going to state the domain of the function and the domain of the derivative. For g of x equals the square root of 9 minus x. Before we start, let's just look at the domain for this. When you have a radical like this, the inner part under the radical has to be greater than or equal to 0. So let's just set that 9 minus x is greater than or equal to 0. That means 9 is greater than or equal to x when you add x to both sides, or x is less than or equal to 9. So that's your domain for g. Now let's go ahead and find the derivative, and then at the end of the video we'll talk about this again. We're going to compare the domains. Now, this is your definition of derivative. I have this on my Facebook page if you ever need to save a photo of it. And we're just going to take g prime of x. I'm going to scoot this over because I'm going to have to write a lot on this one line. So g prime of x is going to equal the limit as h approaches 0. And then we're going to do this first part, f of x plus h, or in our case it would be g. So you're going to take your square root of 9 minus your x, and your x now is going to be x plus h. All right, minus your f of x. So minus just your square root of 9 minus x, because ours is going to be g of x, all divided by h. Now from here, the problem is this h in the denominator. So what we're going to do is multiply the numerator and the denominator by the conjugate. And what that means is I'm going to take, this is going to be like my a minus b part, and I'm going to have my a plus b part, so I can get a squared minus b squared. So basically we're just multiplying by the same thing, but change the sign. So 9 minus x plus h, instead of minus put plus, square root of 9 minus x. All right, and then you're going to also have to multiply the denominator by this. So square root of 9 minus x plus h plus square root of 9 minus x. All right, so this is going to give you the limit as h approaches 0, and what we're doing is squaring the a. So you're taking your square root of 9 minus x plus h and squaring it minus your square root of 9 minus x and squaring that, all divided by h times square root of 9 minus x plus h plus square root of 9 minus x. Now, this is to save time on the video. I'm going to let this piece right in here for now equal d. So I don't have, because we're going to have to keep copying it down and it's going to waste time for the video. So let's get to the numerator. The numerator is going to be the limit as h approaches 0, and you square this, you're going to get 9 minus x minus h. When you square this radical, you're going to get negative 9 plus x, all divided by h times my d. Okay, so now let's simplify our numerator. We have the limit as h approaches 0, and the 9's cancel and the x's cancel. So we have negative h divided by h times d. And what's going to happen is the h is going to go into h one time. So it's going to be negative 1 divided by our denominator. So now let me write, and this h here will cancel as well. So now we're just left with this in the denominator. We're going to have the limit as h approaches 0 of negative 1. Now here's our denominator again. We're going to have 9 minus x minus h plus square root of 9 minus x. Now all we have to do is substitute this 0 here for this h. So basically we have the limit as x approach, well, we don't even have that. Once you substitute in your 0, we have this equals negative 1 divided by square root of 9 minus x times 2, because we have 2 of these. All right, so this is your final answer. Now, the thing is with the domain. Remember, our domain for this was x is going to be less than or equal to 9. Or we could say negative infinity to 9. So that's your domain of G. Your domain of G prime is the same thing. It's going to be x is less than 9. So that means it's going to be negative infinity to 9, open interval here. And that's because this cannot be 0. You cannot divide by 0. So that's why these domains changed. This one we didn't have to worry about the 0 because you can take the square root of 0. But this wasn't in the denominator. So that's the difference between the two. Thank you. Have a nice day. Bye-bye.